Welcome, class. This is Mr. Tinich back at you with our Chapter 1.5 notes over angle relationships. As always, please make sure to put the date at the upper right-hand corner of your notes. All right, so the first part that we are going to look at are relationships between angles, which there are multiple that we're going to go through. The first relationship we're going to look at, the definition are two angles that lie in the same plane, have a common vertex inside, but no common interior points. Now, what we would call these two angles would be adjacent angles. So adjacent angles are two angles that lie in the same plane, have a common vertex inside, but no common interior points. Okay? Easy way to think about adjacent angles. Adjacent means they are side by side. So when we look at our diagram, two angles that are side by side are angle 1 and angle 2. Now we look at our second diagram, and we have angles 4, 5, and 6. Now remember, two angles that are adjacent mean that they are side by side again. So in this case, there are actually a couple pairs of adjacent angles. We could say angle 4 and angle 5. We could also do angle 4 and angle 6. Finally, we could also do angle 5 and angle 6. Those are all side by side. Now we are going to look at examples that are not examples of adjacent angles. So this means that they are not side by side, or they do not have, or they have common interior points. So an example in this case of two angles that are not adjacent are angle 3, which I'm going to shade, and also angle EDF. So we see here they actually share a portion. So angle 3 is not, it is next to angle EDG. However, EDF at angle 3 are not examples of adjacent angles. Now the next portion we are going to go on to are vertical angles, which can simply be defined as two non-adjacent angles formed by two intersecting lines. Again, that is two non-adjacent angles formed by two intersecting lines. The easiest way to think of vertical angles are angles that are right across from each other. So in this case, we have two angles such as angle GBK and angle ABE that are vertical from each other because they are directly across from each other. Or we can also say angle ABG and angle KBE. Now something that's very important that you guys need to know, and this will be something that we will be using throughout the entire year in geometry, is that vertical angles are congruent. So in this case, we know that GBK is congruent to angle ABE, and also angle ABG is congruent to KBE. Now to continue on with our notes, we are given another definition, which is stated as a pair of adjacent angles whose non-common sides are opposite rays. This definition goes to the vocab word linear pair. So a linear pair is a pair of adjacent angles whose non-common sides are opposite rays. The big key word in this definition are opposite rays, which remember what we learned in 1.4. Opposite rays are rays that have a common endpoint that point in opposite directions. So it actually creates a line. So that's what opposite rays are. Now when we look at our diagram, we are given two different angles with one opposite ray. So in this case, the opposite rays are going to be DB and BC. So we have ray BD and we also have ray BC. That's our opposite rays. Now, a linear pair would be this example. We have angle EBD and angle EBC. Now, the big importance of linear pairs. Linear pairs actually create supplementary angles. Now, if you guys remember, supplementary angles always equal to 180 degrees. So this means that if we were to add EBD and angle EBC, those would sum up to be equal to 180 degrees. That's what also makes it a linear pair. Now in example 1, part A, it tells us to name two obtuse vertical angles. Now remember, obtuse means that we have to have angles greater than 90 degrees. Now when we look at this problem, we see that AGB is obtuse because it is greater than 90 degrees. It's 115 degrees. Now we need to find the vertical angle with AGB. Now, the easy way to look at vertical angles, we are going to look at the two lines that form the 115 degrees. So this 115 degrees is AGB, and the vertical angle is the angle right across from it. So in this case, the other angle we are looking at is angle EGC. Okay, so the two obtuse vertical angles are angle AGB and also angle EGC. So those are both right across from each other and create two vertical angles. Alright, now the second part we're going to be looking at are naming two adjacent acute angles. Remember that acute means that we are looking for angles that are less than 90 degrees, and adjacent means that our angles are side by side. Now there's actually multiple examples of adjacent acute angles. So by looking at these, we know that 65 is less than 90 degrees, and so is 50. Those are both less than 90, so that means those are both acute, and the definition of adjacent means that they are next to each other. So in this case, we can say AGE and also EGD, angle EGD. Now something I want you guys to do, there are actually two more sets of acute adjacent angles. All I want you to do is list for me one set of acute adjacent angles. Now please go on to part 2 of Chapter 1.5 notes over angle relationships.